Good morning and welcome back to Battlesnake Official on Twitch TV. We're really excited to be here with Brandon Brown of Echosec for round two of the TypeScript and Heroku tutorial.
All right. Good morning. I hope everyone is wide-eyed and cheery. I'm Brandon. I work for a company called Echosec out of Victoria, BC. I'm a QA developer there, so I do a lot of work around ensuring that our product is up to the best it can be for our customers. Today, I'm going to be talking about sort of following the lead that I've created building a snake with TypeScript. And last time, just to recap, we created a snake where it can actually go and find the next piece of food. And we wrote some code to do that. But today, what I'm going to do is I'm going to show you how you can test that code to ensure that your snake is actually making the right decision. And I'm going to go through some tools on how to do that. So what I'm going to do is share my screen here so that I can show you some of what I am doing. All right, so over on the left here, you should see my code editor. And over on the right here, I've got a browser up where I'm going to demo some of the API docs and all that sort of stuff. But let's do a recap here. So some of the things that we've done, we've forked the starter snake node project from GitHub. And if you haven't done that yourself, you can go to github.com/battlesnakeofficial/starter-snake-node. And what you can do is you can click the fork button there. If you've done that, it will take you to your own fork of Battlesnake or of the starter snake. And we can start hacking on this. The other thing that we've done is we've converted it from JavaScript to TypeScript. So one of the things that when you get for free from this project is you get a JavaScript snake. But today what we're doing is we are going to be doing some TypeScript work with it. And so what we've done to get to this point is we've converted it from a JavaScript project to a TypeScript project. Now, those are the things that we've done so far. We've also added in the ability for the snake to move around and find some food and stuff. But what we're going to do today is we're going to add some linting and code formatting to ensure that your code has consistency across if there's any team members working on your team for your snake, or if you're just by yourself and you want to ensure that your code is built to the appropriate standards for coding. We're going to add some unit testing to ensure that our code doesn't break between changes. So if you make a change to the algorithm that's generating the moves for your snake, then you might push something accidentally and your snake might not respond properly or appropriately how you've designed it or how you've built it or coded it. So we're going to add some unit testing there to ensure that our code doesn't break between changes and that we can catch those issues and those bugs earlier on rather than finding out in production that our snake has just bit the bucket in the middle of a tournament. So. And then I'm going to show you how to use another couple tools for being able to test your snake. But let's jump right into it. So what I've done is I've gone ahead and I've done this step right here, which is add linting and code formatting to ensure consistency for our code. So one of the tools that we're using for doing this is a tool called ESLint. And the long and short of it is that ESLint is a project that is available to be able to ensure that your code matches a specific set of rules for any given plugin that you want to use. So specifically around JavaScript, they have a bunch of rules where you can specify what sort of plugins you want to use, what sort of rules you want to abide by. Say you don't want console log entries and stuff in your code as it's going into production. You can ensure that your code doesn't have all of that. Another tool that we're using is called Prettier. Now, Prettier, this is kind of a personal choice. However, Prettier is one of the tools that is pretty widely used in the development ecosystem. It's a very opinionated code formatter. So basically what it does is it takes your code that is potentially misaligned and not indented properly or outdented improperly, all that sort of stuff, and it takes that code and squishes it together into a properly formatted file. So the best way I can demonstrate this is if I take some code that we already have written and I kind of mess it up a little bit, and you can see that these red lines here are showing up. These are the ESLint plugin to my code editor, which is VS Code, telling me that there's some errors with my code, and I have an option called format on save turned on in my editor. So when I go Command S, it automatically fixes it for me. So it runs it through the Prettier tool, and it generates a representation of your code, and then properly formats it and reinserts it back into your editor, all in sort of real time. So that's just one way to ensure that your code is going to be properly formatted. If you're working with multiple people, then it's a lot easier to explain if different people have different coding styles, that you have one sort of central way to write your code. And that's all taken care of you because you don't have to make that choice. The tool is doing it for you. Okay, so those are the two tools we're going to use for code formatting and ensuring that we don't have any sort of errors in our code and the syntax, all that sort of stuff. The other thing that we're going to do is we're going to add some unit testing. And now, again, I've already gone ahead and done this, but I'll walk you through what I've done to get to this point. So there is a tool called Jest by the Facebook open source project, Jest testing. And Jest is one of many tools for testing, but it has a really, really nice, simple interface to working with. You simply just have to create a folder in your project where you're going to house your tests for testing your code, and then you simply just run the tool itself. So the way that we're going to do that is we have an Npm Run script called test. So if I say Npm Run test, this is going to run our tests, and I've already got a bunch written. And so what we'll see is we'll see the output here, and hopefully these all pass. I was making some edits earlier, and we'll see that so the tests that we have written in here, they all pass. So let's go and let's explore how we got this in here first. So, I'm editing in the wrong editor there. Okay, so let's go and see. So the best way to get it in, the easiest way to get it installed is simply to npm install --save -dev jest. Now, there's some intricacies with running this with TypeScript. There's a couple other packages you have to install. One is ts jest, so you can install that alongside. It basically just runs your code without having to do the compilation step, and just makes it a lot easier to work with. For all intents and purposes, if you're just running the stock starter snake node project, you can just say npm install jest, and that will just install the base package there. So there's a couple others that you need to install in order for the ESLint plugin and Prettier plugin and stuff to work. I'm not going to go into details about how all that stuff's configured because, again, it's a very personal thing. And there's a whole lot of resources out there that show you how to get it set up. So we will skip that for now. All right, so configuring Jest, you can get very complicated. This is a fairly somewhat complicated setup. The easiest thing to do is just simply run Jest, and it will try its best to discover some of the tests that you've already written, or if you have any test folders, or it will basically just say there are no tests found. So for our setup here, we have our Jest config, and where our tests sit is this __tests__ folder. And inside of that, we have our snake directions tests. Now, if you look at this, you'll see that there's some strange looking ASCII art here. And you're probably wondering, WTF, what is that? So one of the things that at working at Echosec, we have a team that we're working on our bounty snake for the previous event, and we created a way for us to generate a game state given some ASCII art effectively. And the way that we do that is each of these lines is a empty space. And however many wide there are is how wide the board is. And however many rows there are is how high the board is. So this will generate the height and width of the board for us. Zeros are represented as food, which is the closest representation we could come up with for what it actually looks like on the game board. And then the head of the snake is a capital S character. The lowercase t is a body piece, and the uppercase T is the tail. So S is the head, T is uppercase T is the tail, and anything in between is just represented as a lowercase t. So that's a snake type. And then the 0 is the food. So how do we get this into a usable game state? Well, we've written some code to generate a game state given this sort of ASCII art. And we're actually in the process of potentially open sourcing this project. So I wouldn't pay super close attention to it. We want to clean it up. But the basic idea here is that we have this function that takes ASCII art like this, parses it, and then generates something that looks like a sort of JSON blob for game state that looks kind of like this. So in a move function, we have the game, the turn, the board, what U is, and everything sort of in between. And so what we do is we take this ASCII and then we generate a JSON blob that looks like this that we can then test against. So an improvement from last time, if you've watched the previous tutorial, is that we had some of our decision making directly in the move endpoint of our snake. Now, what I've done is I've gone ahead and moved some of that logic into a function that resides in our helpers file. So the helpers file just contains a bunch of functions that we had originally inside of that move endpoint. So we moved it out so that it is a lot easier to test. And also it declutters this move endpoint because it's now only 3 lines of code long rather than the 40 or 50 that we had before. So now we've moved all of our work over to this helpers file, and we can do all of our changes and stuff here, as well as run the tests to ensure that any changes that we actually make aren't breaking. So let's demonstrate that now. One of the cool things that you can do with Jest is you can, instead of just having to run it every single time that you want to run your tests, Jest has a watch mode that we can enable. And I'll enable it as soon as this is done. So with Jest, it's kind of smart. And what it does is it watches to make sure that it's not going to process anything if nothing's changed between the last time it was ran. And so we can see that here. It says no tests found related to files since last commit. So if we go ahead and we change some files in here, like let's say we're going to always return right, regardless of our brain here of always choosing a specific direction. Actually, that's not going to compile, so we won't do that. What we'll do is let's change up. Where is, okay, so we've got the coordinates. Let's go back to our snake test here. So in our test, what we're doing is we're taking that ASCII art, we're generating a game state from it, and we're specifying what turn we want that state of the game to represent. And so what that's going to come through as is the turn number here in the response that's returned back with the game state is going to have that turn number 8 sort of injected into it. We can also do some more configuration. So if we hover over this, you can see here that we can pass in specific height and width of the board if we want to override what is there. We can specify the health and turn number and that sort of stuff. So given that, we now have a game state that we can make use of. And so in the index for the move function, if we take the data that's in the request body, which is the server request containing all of the game state, and we pass that into our now created decide direction function, we can then determine whether what move we wanted to actually take. So let's go and take a look at that function. So again, like I said, we've moved a lot of the functionality from the move endpoint into this decide direction to make it easier to test. And we know that this function takes a data object, which is the interface for the server request, which is what we created last time. So let's go and update this test. So given that we have the game state, which is the iServer response, and we decide a direction, we can assign a move, and we can expect the move to be the right direction. Now, if we change this and we save, we can see that our tests rerun without us having to do anything. And this test should fail, as it did. And the reason that it failed is because we expect this move, given this particular game state, for our snake to go right. So in our fairly simple logic that we have inside of the moves here, we are specifying that we want to go towards food. And specifically, we're going towards the first food in the array, not the closest food, because we haven't determined what closest food means to us. So what we're doing is we're going towards the first food in the array. And so now if we take a look at this, we can see that the first food in the game board is at this coordinate. So given this scenario where the head of the snake is right here, we do expect this snake to go right. So we can actually test for this. And we have this test here. And if I change this to right, we can see that this test should pass. All right, and because it was already passing before, it's not actually going to do anything. So what we'll do is we're going to create another state. We're going to copy that, and we're going to say the snake should actually go left. So instead of having the food over on this side, we're going to replace that with a hyphen, and we're going to move the food over to here. So again, this is going to be the first food on the board, and we should ensure that this snake should go left. Now, we haven't changed anything since we copy and pasted the old test, and we're ensuring that it should go right, but it's going to fail because the snake actually isn't going to go right in this case. So we need to change this to make the snake go left, and we can ensure that it's going to go left by enforcing it via this test. And there we go. We have a excuse me, we have a snake that is going to go left. So what we can do is we can cover a couple pieces here and say the snake should go up. And so we'll put the piece of food up over here. And we're going to keep this piece of food here because technically this is the first on the board and it should go for this one. So let's say up. And running the tests. And so the test should show that we have 3 tests. And it is failing probably because we are in our code. It is going to go over to the left and then go up, likely. So let's move the food right here and make it a lot easier for the snake. Remember, the logic for our snake isn't very good. So we do expect the snake to go up, but we have to make sure, for our sake right now, the food does have to be in a specific spot in order for us to know that the snake is going to go up. So because we had it on the left, the snake is likely going to make a left turn over and then go straight up rather than going up and then going over to the left. Okay, so we've ensured that our snake is going to go up. And now what we can do is ensure that our snake is going to go down in this case. So if we're going to go down, we definitely want to make sure that the snake is in the proper position. So we're going to swap the tail and the head and go like this. And then we will put food here and remove these food from the board. We definitely know that this snake should go down because there's only one food on the board, and because our logic is very simple in that we're getting the very first food, which is the only food in this case. So let's just make sure that we have our names correctly here. So we'll save that, and we can see that the tests are running and that we should see that this last test here should pass and that our snake should go down. That's great. Now what we can do is we can make changes to specifying where the food is on the board, finding the coordinates for any of a given food. Say we don't want to go for the closest food, or if we want to go for the farthest food, that sort of thing. What we can do with these state checks is ensure that the changes that we're making to our snake AI are actually being impactful and ensuring that our code isn't breaking between changes, so that we don't have a dire scenario where our snake is going to die during a tournament, because that would not be good. All right, so this is the testing sort of harness that we created at Echosec to sort of deal with this problem. Now, if you decide that you don't want to do something like this, there's another way that you can test your snake. Not necessarily in the traditional sense of testing, but you can get a little bit more comfortable with how a snake is returning given a specific move set. And what I'm going to introduce here is a tool called Insomnia. So Insomnia is a REST client. It effectively does network requests and shows you what the response is. The benefit to us using this specifically in the Battlesnake context is that what we can do is we can set up a bunch of endpoints to post against, and we can effectively replicate what our snake is going to expect to receive and respond with. So I have a snake little move set up here. And so I'll kind of explain how this interface is working here. So what you have over on the left here is you have requests. So these are requests that we have set up, and these are going to represent where we are posting to or where we're getting to. I've named them what their HTTP method is and the endpoint that they're posting to, but you can name these whatever you want. If we wanted to name this make move snack, we can do that. But for the sake of this, I'm just going to name them what they actually are doing, because it's a little bit easier for me to visually parse. So from here, we have our move. And normally what happens is when you create your first request, we're going to do test request. You can select what HTTP method you want. And for move, what we want is we want post, and we want JSON body type, because that's what we know that we're going to send, or what our snake is receiving. Okay, so you get presented with a blank sort of editor. And from here, what this is expecting is we're expecting a JSON body type. Now, the very, very minimal, most basic JSON body type is simply just an object, an empty object. But what we're going to do is, because we know that the Snake API, the Battlesnake API, gives us JSON payloads, we can go and we can copy this from here and then paste it into here. And so now what this is going to do is this is acting as if Insomnia is the Battlesnake server, and it's going to send a JSON payload to your snake. Now, we haven't defined where that snake is. So let's go and say, we know that our snake runs on a specific port. So we're going to close, we're going to close our tests. Actually, what we'll do is we'll open up a new terminal here. And we are going to run Npm Run Start. So what this is going to do is this is going to run our snake on port 5000, because that's what's hard-coded into the package. And so now we can see that it is running on port 5000. So let's go and say localhost port 5000. So this is where our snake is going to live, or it is living right now. So now what we can do is we are set up to send a post request to this endpoint with this JSON payload. We don't really have to add anything else here. So what we're going to do is click send. And so now we can see that our Battlesnake is alive. Oh, I forgot to put the move endpoint here. So actually, this is a good demo of the default endpoint, which is the root of your Battlesnake, which in the README says that if you just go to it in a browser, you'll see your Battlesnake is alive. So this is basically just replicating that. What we actually want to test is the move endpoint. So we're going to go and click send. And what we get back is what the Battlesnake API is expecting, which is the move on a specific move. So now what we can see is over on the left here, we're running our snake, and we can see that the post endpoint was hit, and there was a 200 return, and the left move was calculated to be sent back, given the board state that we passed to it. So what we can do now is we can run this over and over and over, and we can see that given this specific board state, we know that our snake is going to go left. So now what we can do is we can play around with some of these parameters. So let's say, so we have a snake, we just have, one snake on the board, and we have food at this location. So let's say we want to add more food. Now, this is where it kind of gets tricky because you have to work and sort of think in JSON. But what we can do is we can say there's food at X4 and food at X or at Y9. Let me just make sure that's within the bounds of the board. 15, yep, we're good there. So now if we click send, the snake is still going to go left because we're going to go towards the first. We're going to go towards the first piece of food. So let's remove the original first piece of food and click send. So now our snake is going to go right because the way that the board is represented, if we want to, we can actually take this scenario and we're just going to replace this. So let's rebuild this particular game state with our ASCII art because it might be a little bit easier to visually see how this works. So we've got food at X4 and Y9. So let's go over here. 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is where our food is. And our snake is at X1 and Y3. So that is where our head is going to start. So let's replace these. X1, 1, and 3. So right here. So likely what's happening is given the state of our snake, if we say that this should go right, and we switch back to this, so we switch back to our tests, we can test that given this state, our snake should go right. And we can see that because our test is actually passing now. So let's give this a rename. Should go right. Just name that with number 2. Okay, so the other thing you can do with this is you can test to make sure that the endpoints on your snake are actually working correctly without having to open up a browser or do anything. So again, we have our test request here. So we're just going to delete that. So just a quick sort of gut check is you can click send, or you can go Command Enter to actually send the request. We're going to send this request again. We're going to send this request again and send this request again. So what we can do is we can visually see that our snake is working on all of the endpoints. And we know that because we get a 200 OK, which is the sort of standard response for everything went fine, nothing is wrong. Okay, so this is, Insomnia is a very powerful tool. You can use it to test HTTP endpoints. I'm a huge fan of it. And if you want to get started, I think someone posted it into the chat. So let's minimize that for now. And let's get back to our tests here. So just sort of to recap, what we've done is we have implemented a testing harness to ensure that our snakes make correct decisions given a specific board state. The reason that this is helpful is because we know that our snake can make decisions, but given a specific scenario, we might not, our snake might not make the right decision. So what we can do is we can ensure that given a specific state, we can say that given this state, our snake should always go right, or it should always go left, or up or down. So we can hard code that, and we can ship that along with our snake to ensure that every time that a given state is sent to it, that snake is going to make the correct decision. So the last piece to this is, where is it here? I think actually I might have covered it. Yeah, so we tested with our game state sort of harness. Again, there might be a moment in the future where this gets open sourced and you can actually just sort of plug this into your snake and be able to use it. Right now, it's kind of hard coded into our snake, and there's some intricacies with it. We want to clean it up, all that sort of stuff. We've also demoed with Insomnia how you can ensure that your snake is going to be tested correctly and that the proper responses are sent back, and just kind of get a gut check that everything's working. But definitely the testing portion of this is probably the most important part. And the being able to visually see things as board states given our sort of ASCII art here is incredibly helpful. All right, so that's going to wrap up my little tutorial today for being able to test your snake. I hope that you find some of these tools useful. Definitely go and try Insomnia. It is a great tool for not just testing your snake, but using for testing any HTTP API endpoints and sort of using it to explore new APIs, as well as our testing framework harness type thing here. We'll see if we can get that available to the rest of everyone within Battlesnake. All right, until next time, thank you for tuning in, and I'm going to hand it back to Noah. Thanks, everyone.
Thanks, Brandon. That was awesome. Really appreciate you giving us some of your time to run that tutorial, and I know a lot of people are going to like it. All right, thanks, everybody. Thanks for tuning in, and hope to see you back later today at 1 p.m.